Welcome back guys to SPF tutoring. In this video we will learn about trigonometric ratios. So what are trigonometric ratios? We will learn about them, and we will also learn what SOHCAHTOA means. So first we should get familiar with right angle triangle. So a right angle triangle will always have a 90-degree block sign like this, which means it's 90 degrees from that angle. And usually when you use these trigonometric ratios, you will have a missing side length or a missing angle. So in this case, we will draw a missing angle, and missing angle is usually labeled as theta. And right across theta, the side length is called opposite. And the longest side, which is usually across the box, which is known as a right angle indicator, that is called a hypotenuse. I'll just short form it. And the last length is called adjacent. So in right angled triangles, we will have three trigonometric ratios, which are called sine, cosine, and tangent. So sine is always opposite over, so that means divided by the hypotenuse. And cosine is always adjacent divided by the hypotenuse. And tangent is always the opposite divided by adjacent. Now you're probably wondering, how should I memorize these? And it's probably gonna be so difficult, but it's not, because this acronym here, SOHCAHTOA, that's literally, it helps us memorize these trigonometric ratios really easy. So S, this first S over here, means sine, and O means opposite, and H means adjacent. So it means sine is always opposite over adjacent. Same thing here. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So this SOHCAHTOA formula helps us memorize these trigonometric ratios very easily. Now let's do one example, and let's see how these ratios work. So we will have one right angle triangle here, and in this triangle we will have all sides, but we won't have the angle in between the lengths. So we will have, so for our adjacent side we will have 3, for our opposite we will have 4, and for our hypotenuse we will have 5, and this is our theta. So now we want to find our theta value, and how do we do that? So we put our acronym here, SOHCAHTOA. In this case we have all our side lengths, so, and we need to find our theta value. So that's why we can use any of these ratios to find a theta value. So let's do all of them. So for sine theta, it's opposite over hypotenuse. So opposite is our 4, because that's right across the theta value. So 4 divided by 5, because that's our hypotenuse. And let's do it for cos now. Cos theta is adjacent, so 3 divided by 5, because that's our hypotenuse. So if we want to calculate these ratios, the theta angle, we need to use our calculator for this. So make sure your calculator is in degrees. And now we gotta use, let's solve all of them. So for sine, whenever we want to find the theta value, we always isolate for theta. And theta is isolated by, if we have, for example, in this case, if we have, let's do sine first, sine theta equals 4 over 5. We want to make sure theta stays on one side and sine goes to the other. So for that, we got to use sine inverse. It's usually put like that, sine inverse of 4 over 5. So now we just put this in our calculator. So theta equals, so if we put it in our calculator, that's sine 4 over 5 equals 53.13. In math, we usually do 3 significant figures. So theta equals 53.1. And theta, since it's an angle, so we gotta make sure we put our measurement in it, so that's degrees. So 53.1 degrees. So, and remember, we had all our sides, so we could use any of them, any of the trigonometric ratios. So S for sine, cosine, or tangent. So if you want to confirm, we could just do cosine as well. So cosine theta is 3 over 5, and theta will be cosine inverse of 3 over 5. So put that into our calculator, and we get 53.13 again. And we gotta make sure our significant figures are to 3 digits, so that will be 53.1 degrees. Now if we do the same thing to tangent, we could test it out. It will be the same thing, so 53.1. Now let's do an example which is a little complicated, but it's not that complicated. It just has a few more steps than the usual one. So now first we gotta find x and y. So in this case we need adjacent and hypotenuse. So first we gotta use the easiest method. So first, actually we should write SOHCAHTOA so we could use it later. So SOHCAH and TOA. So in this case, let's use sine. So y. First of all, we could start finding the y value, which is here. So with sine, we could use this 45 angle here, and we could use sine of 45 degrees equals, so we could use its opposite over hypotenuse. So opposite in this case is 5 divided by, and our hypotenuse is y. So first, since it's y in the denominator, we gotta bring it up top. So we gotta do this whole thing times by y. So it will be, and then this sine 45 will go on the bottom. So y equals 5 divided by sine 45. And if we put this in our calculator, y equals, let's do it. So 5 divided by sine of 45. So that is 7.07. So this is not degrees, it's a side length measurement, so it's not in degrees. Let's just put meters here as our units. So this will be 7.07 meters, our y value. So now we gotta bring a step forward. Now we gotta find the x value. So let's clear this little up. So now we have our y value. Let's redraw the diagram. So y is 7.07 meters. This is 5 meters. Now this is x meters. And now this is 45 degrees. And this right angle box. So now we need a ratio from here, which we can put x in. So in this case, we gotta think about it. So if we do sine will be 45 of sine, opposite over hypotenuse. So we could use that if we use this 45 degree here. But for our practice, let's do something else. So if we do cosine, that's adjacent over hypotenuse. So adjacent, if we use this 45 here, that will be adjacent, so x over 7.07. So we could do that. So let's use it. So cosine is adjacent over hypotenuse. So cosine, I put theta here. So cosine of 45 degrees is x over 7.07. So now let's get a little more space. So now we gotta solve for x in this case. So now we have 7.07 in the denominator, and we could bring it up top here. So 7.07 times by cosine of 45 equals x. Now we put it in the calculator, and then let's see what comes. So x equals 7.07 times cosine of 45. So that is 4.99, and we gotta round it to 3 significant figures. So that is like approximately 5, but let's leave it like that. So x is 4.99 meters. So there you have it. So y is equal to 7.07, which is here, and now x is equals to 4.99, and we could just add it to the diagram. So that's how you find these missing angles and missing side lengths by using our trigonometric ratios. That's all for this video. See you in the next one. Thank you for watching this.